Dear students, a very happy morning to all of you. Today I welcome you all in e-lecture 17 and we are going to discuss water quality standards in this lecture. After studying this, you shall be able to know the need to define water quality standards in relation to its particular use, criteria, and various parameters. Also, you shall be able to identify the factor that influence water quality criteria. Water, as you all know, is an essential component of life. As rightly said by Mahatma Gandhi, next to air, water is a necessity of life. We cannot live without it for more than a few days. Just as without air, we cannot live for more than a few minutes. Therefore, as in case of air, nature has provided us with ample amount of water and drinking water must be pure. Now, if we look at the distribution of global water, we see that an earth is full of plenty of water. But potable water, water for drinking, this amount is very, very less. From this total amount, only 2.5% is present as fresh water. And out of 2.5%, 30.1% of this 2.5% is present as groundwater and rest is frozen. You will be shocked to know that fresh water is only available in 0.26% as in lakes and 0.006% as in river. Water bodies have many uses such as agriculture, multiple industrial, fisheries, and recreational use. The term quality must be considered relative to the intended use. So basically, water quality standards refer to the chemical, physical, and biological characteristics of water. It is a measure of the condition of water relative to the requirement of one or more biotic species or to any human need or purpose. There are many aspects of water pollution, and there are many variables that determine water quality for a given use: biological, physical, and chemical. So, biological includes microorganisms, cellular, and microscopic bacteria. They contaminate ground and surface water and causes waterborne disease. Physical includes dissolved and suspended solids. Plants, leaves, etc. become part of the suspended solids. Ions like nitrates, hydroxides, chlorides are completely soluble in water is called a dissolved solids. Chemical includes solubility, chemical reactivity, temperature, and high acidity, toxics, and carcinogens. Let us take an example. For example, water for domestic use should be free from all type of suspended, dissolved, and microorganisms, whereas water for boating and swimming pool purpose standards are less vigorous. Set by each state, water quality standards regulate how clean water should be in water bodies. State designates water bodies for specific uses based on their goals and expectations of uses. Various goals are protection and propagation of fish, shellfish, and wildlife, recreation, agriculture and industrial use, and public water supply. Water quality standards are the basis of the water quality control program directed by various authorized agencies, and various water quality standards are as we see here in this slide: turbidity, salinity, BOD, COD, microbial count, bioaccumulation, hardness of water, total dissolved solids, pH. Now, biochemical oxygen demand and COD will discuss here in the slide. So, biochemical or biological oxygen demand is the amount of dissolved oxygen needed. That is, this is the demand basically by aerobic biological organisms to break down organic matter present in a given water sample at certain temperature. This is an indicator of pollution. When high pollution, then there will be less dissolved oxygen or greater consumption of dissolved oxygen will be there. And low BOD indicates pure water. BOD for drinking water should be in the range of 0.75 to 1.5 ppm. Now, COD, this is a chemical oxygen demand, and this is the amount of oxygen necessary to oxidize all of the organic carbon completely to carbon dioxide and water. COD is a measure of water and wastewater quality. The COD is often used to monitor water treatment plant efficiency, and this test is based on the fact that a strong oxidizing agent under acidic conditions can fully oxidize almost any organic compounds to carbon dioxides. So both of these standards are very important in designing quality of water. Now, hardness, alkalinity, and nitrate. So, we first talk about hardness. We all know what is hardness. Hardness of water is due to the presence of bicarbonates, chlorides, sulfates, and nitrates of calcium and magnesium. And water which doesn't produce leather with soap solution easily is we call as hard water. And harmful effects are linens and clothes look dull and feel rough. There will be ugly stains on white porcelain, and there will be low water pressure because of clogged pipe due to hard water. Desirable limit is 200 milligrams per liter, and permissible limit, which we can tolerate up to a certain extent, is 600 mg per liter. Risks or effects, scales and utensils and soaps, sources, dissolved calcium and magnesium from soils and aquifer, and treatment by boiling, water softening, ion exchange, lime soda method, etc. Alkalinity. This is the capacity of water to resist changes in pH that would make the water more acidic, and this is a desirable limit. Permissible limit is 600 milligrams per liter. Low alkalinity causes deterioration of plumbing fixtures and sources hazardous waste landfills. And how we can treat is by adding neutralizing agent. Nitrate level in our water resources has increased in many areas due to application of fertilizers in agriculture. It causes blue baby syndrome. And what is blue baby syndrome? This is the disease baby's skin turns blue because of less amount of hemoglobin in the blood. Sources, fertilizers, natural deposits, household wastewater, etc. And treatment we can do by distillation, reverse osmosis, and ion exchange process. You may have heard the term pH to describe drinking water quality, and we all know that acidic solutions have low pH. Water with very low or high pH can be a sign of chemical or heavy metal pollution. Then permissible limit, and this is the ideal one for drinking water, is 6.5 to 8.5. Low pH, this will cause corrosion, and high pH will cause the taste of like soda in the water and various deposits. Treatment, if increased pH, so we can add soda ash, and if there's a low pH, we can add citric acid. TDS, this represents total concentration of dissolved substances in water. If more TDS, it means more hardness, and high TDS makes water of bitter taste. This is the desirable limit, and this is a permissible limit. This is the sources, landfills, and dissolved minerals, and how we can treat by reverse osmosis, distillation, and ion exchange process. Now we talk about turbidity. This is the turbid water we can see here. It is a measure of dispersion of light in a column of water due to suspended matter. Higher the turbidity, the clouder water appears, and then it loses the ability to support life. And the treatment of turbidity is by adding activated carbon and oxidation and filtration. Now, coliform bacteria. We all know that our drinking water should be free from coliform bacteria. So, desirable limit is nil. Risk or effect, this can cause gastrointestinal illness. Sources, various livestock facilities, septic systems, manure lagoons, household wastewater, and treatment by chlorination, ultraviolet distillation, and iodination, etc. Now, arsenic. Arsenic's desirable limit is zero point zero 0.01 milligrams per limit, and the maximum limit we can tolerate is permissible limit. This is zero point zero 0.05 milligrams per liter. Risks or effects, weight loss, skin cancer, Nervous system toxicity, and this is an example of a skin cancer due to arsenic poisoning in water. Various sources previously used in pesticides, improper waste disposal, or product storage of glass or electronics, minings, and rocks, and how we can treat arsenic poisoning by activated alumina filtration, reverse osmosis, distillation, chemical precipitation, ion exchange, lime softening, etc. Hope you enjoyed the lecture. Thank you. Happy learning.